Hey folks, here's an example of another empirical formula question. Let's go through it together. So if you want to attempt this by yourself, just pause the video right now, and then we're going to walk through this together to show you how we can solve this equation. So if you'd like to pause it, try by yourself, highly recommended. Pause it now, and then we'll take it up. Okay, welcome back. Let's take a look at this question, and let's see how we can solve this empirical formula question. The first thing that we need to know is what is the amount of mass that we have of every single element. And what we can see is that we do have percentages given to us. These are our percent composition by mass. It even says that right here. Now, it doesn't always have to say that. It just does in this particular case. We can always assume that it's going to be by mass. Next thing that we need to do is we can assume that we have 100 grams of the sample. That will allow us to convert our percentages into grams fairly easy. Now, what we're going to do, and it's not highlighted here, but I'm going to add these two decimal places. That was what should have been done, just to show a little bit more precision. And again, these things should all add up to 100%, which they all do. So let's lay out our equations or our elements. We have C, we have H, and we have O. Now, of carbon, we have 40%. 40% of 100 grams is going to be 40.00 grams. Hydrogen, we have 6.67%, which is going to be 6.67 grams. And then oxygen, we have 53.33 grams. We now have to find the molecular mass or the molar mass of each of these elements, and then use that to convert from grams to moles. So once again, to get rid of this unit of grams, we're going to put it on the bottom. We want to be left with the unit of mole. And the only unit that we know that has both grams and moles is our molar mass. Molar mass of what? Molar mass of carbon. So if you look on your periodic table, the molar mass of carbon is 12.01 grams per mole. So that 12.01 belongs with the grams. And so I'm going to put it at the bottom here, and we're going to use that to divide. I'm going to do the same thing for the hydrogen and the oxygen. Okay, now we are ready to do our division and find our mole values. Remember that by doing this, all of our grams are going to cancel out, and we are going to be left with the moles that we want. And so again, I'm not going to round this. I'm just going to truncate the number, leave the whole number in my calculator. The value that we get for carbon is going to be 3.3305 mole of carbon, 6.6039 mole of hydrogen, and 3.3331 mole of oxygen. All right. Now, of these, it's pretty close as to which one is the smallest, but the winner is this one over here. It's not too far away from this one over here, but we're going to use the smallest value. We're going to take that value and divide all of these numbers by that smallest value. So we're going to get 3.3305. Now, to save me from writing this number over and over again, I'm just going to divide and then put quotation marks here so that I'm going to be showing that I'm going to be using that same number to divide everything. The result of this is that our moles will cancel out and we will be left with a unitless number. And so the first one's quite easy to figure out. It's the same number divided by the same number. That's going to be a straight 1. Now, if we do the second calculation, what we'll find is that we'll get a little bit of a decimal, but we can round this to 2. And the same thing that we can do on the bottom, we can round this to 1. And there we go. We have just found the subscripts for our empirical formula. So our empirical formula is going to be C1, H2, and O1. Now we know that we have to simplify this, and if you know that you're going to drop the ones right away, you don't have to write them. So this is just going to be simplified into CH2O. And that's it. If you got that, congratulations, and we'll see you on the next one.